So let us start today with, as I told you, we'll be studying about network types, Ospf network types. What are the network types that are there in Ospf? So we have three types of networks: point-to-point network. Point-to-point network means simple as the word only says point-to-point. Okay, point-to-point means one router is over here, another router is connected point-to-point to other router, and this router is connected to this router. This is point-to-point network. Point-to-point network. Okay, this is point-to-point network. Okay, then we have BMA network, broadcast multi-access network, where my DR and BDR are elected. Broadcast multi-access network means here there is a possibility of broadcast. That is why there is something DR and BDR are elected. So how a broadcast multi-access network looks like? What is broadcast multi-access network? In broadcast multi-access network, the routers are connected to a centralized switch or a centralized device, you can say. Switch networks are known as broadcast multi-access network. This is a centralized network. This is a centralized device or something, you can say. And all my routers are connected to this device. Now this type of network is known as BMA network. BMA network. Okay, BMA network, broadcast multi-access network. Now LAN technologies like Ethernet, token ring, Metro Ethernet WAN, okay, Metro Ethernet lines for the WAN. These are your BMA network, broadcast multi-access network. Okay, so routers form neighbors, and all routers form neighbors, and okay, and they are in same broadcast domain. They can also create loops. They can also create loops. Okay, so in this type of network, something known as DR and BDR are elected. DR and BDR are elected. Before moving to DR and BDR, there is one more type of network, that is non-broadcast multi-access network, NBMA, non-broadcast multi-access network. Now this type of as the name only says, this type of network, no possibility of broadcast in this type of network. It is like frame relay type of network, frame relay type of network, okay, in which there is no possibility of broadcast. This is my frame relay cloud. All my clients are connected to this cloud, okay, frame relay cloud. There is no possibility of broadcast over here. This is my non-broadcast multi-access network. So these are the three types of networks. We will see about BMA, broadcast multi-access network, okay, in depth. So as I told you, broadcast multi-access network, DR and BDR are elected. What is DR? DR is designated router, BDR is backup designated router. Okay, DR and BDR are elected over here. DR and BDR. Now these DR and BDR are the same. If you watch cricket, it is same as our captain and vice captain, you can say, in cricket. Okay. Now why we need over here, why we need the DR and BDR? Now what will happen over here? Suppose there is a router added over here, or some network added over here. I not a router. There is might be a network that is added over here. Now this router, suppose I'll number the router 1, 2, 3, 4, 5. These are the numbering of the router. Now this router number 3, what it will do? It will advertise this network, because all are the neighbors. It will send the advertisement to all the neighbors. It will send the advertisement to all the neighbors. Now as we are running Ospf, what the neighbor, if it receives any advertisement, it will pass to other neighbor. Okay, so what A will consider, A will say, I have got a network, suppose any network, 10 dot network, I have got a 10 dot network, I have to advertise to my neighbors. So it will advertise again to the all of his neighbors. except from where it has received. Okay. Then 2 will say, okay, I have got a 10 dot network from router 1. I have to advertise it to my neighbor, and 2 will send it again to 3, 4, and 5 again. Okay. So now what is happening over here? See, I am forming a loop over here. Router number 3 shared the information to 1, 1 shared the information to 2, 2 again shared the information to 1. Now the information is getting looped over here. So this, to overcome this type of scenario, we need something known as DR and BDR. Okay, DR and BDR. So what the DR and BDR will do over here, suppose I elected this as my DR and this as my BDR. In BMA network, DR and BDR are automatically elected. Now in DR and BDR, what will happen? What is the role of DR and BDR? Now every other router, which is not DR or which is not BDR, they are known as DR other router. DR other router. So DR other router will only, if any network is been added or anything is been advertised, they will only share the information with DR or BDR. They will only share the information with DR and BDR. That's it. Now it is the responsibility of DR to share this information to other DR other routers. Okay. Now when this information will be shared by the DR, they will come to know that this is not originated from DR router. This is not a network that is connected to DR router. DR router has got this information from some other DR other router. So they will not reply to anyone else. They will not reply it to anyone else. They will be, every router will only advertise, send the advertisement, send the network information to DR and BDR only. Now the DR is responsible to pass the information to others. Like our in our cricket, it happens that whatever the things need to be shared with the team members, just share it with the captain. The captain will share it to the team members. Okay. And now if my DR goes down, if my captain goes down, there is a vice captain present over on the field who will take the charge as the captain now. Okay, so now this router will become the DR and one more BDR will be elected. Backup designated router will be elected over here. Okay, understood?
Yes.
So this is how DR and BDR are process is done. Now, what is the election process? How they are elected? How DR and BDR are elected? Now they are elected on the basis of some steps or some rules. So first thing it looks is the priority value. Priority value. Highest priority router will become the DR. And the second highest will become the BDR. Okay. Highest priority router will become the DR router and the second highest will become the BDR. Okay. Now highest priority in the sense, if I say all the Cisco's router has the priority is equal to 1. All the Cisco router has priority as 1. So all the router will be having the default priority. The default priority on all the Cisco router is 1. So all the routers will be having the default priority as 1. Now, if there is a tie in priority, then the second thing that it looks is highest router ID. Highest router ID will break the tie. Highest router ID will break the tie. The router with the highest router ID among these 5 routers will become the DR. And the second highest will become the BDR. If there is a tie in the priority. Okay. If there is a tie in the priority, the highest router ID will break the tie. Got it?
Yes.
Then DR, if you make a priority of any router is equal to 0, if you make the priority of a router as 0, then that router will not participate in DR and BDR elections. If any router has the priority value as 0, then that router will not participate in the DR and BDR elections. Okay? That router will not participate in DR and BDR elections. Okay? So if you want that any router should not participate in DR and BDR election, you should just make that router priority as 0. Then if you want a specific router to become the DR, then what you can do, you can go and change the priority to the highest priority, that is 255. You can give the priority between 0 to 255. So you can make this route, if you want to make the router 1 as the DR, then you can go and change the priority value to 255. And if you want some router to become the BDR, then you can give the priority value as 254. Okay.
If you set the priority to 0, would that make them a DR other by default?
Yes, they will by
Okay.
default make them DR other. It will by default make them DR other router. Okay. Just give me a moment. Okay. So understood till here?
Yes.
DR, BDR. Now this DR, BDR election is not preemptive. Not preemptive means if suppose this was my DR and this was my BDR. Now what happened, suppose either this link went down or this router went down. Now this router will become the DR and a BDR will be elected. Suppose this router became the BDR. This router became the BDR, new BDR. Okay. Now after some time this router came up. This router came up. Now this router is having the highest priority as 255. Now when this router or this link will come up, it will not automatically become the DR again. It has to wait for the current DR, BDR to go down. Then only it can come up, it can become a DR again. Automatically, if this router comes up, it cannot become the DR again because there are my DR and BDR already there. Once this DR goes down, this will become the DR. And now this will become the BDR because this is having the priority value as highest than any other router. Okay. Then once this DR will go down, then and only then this router will become the DR router. Okay. This is known as non-preemptive. It is not preemptive. Automatically, it will not become the DR again. Understood? Now, if you want to, if suppose you want that this router 1 should only become the DR whenever it comes up, then what you have to do, whenever if it goes down and some other router takes the charge, and whenever now this router comes up again on the current DR and BDR, this was my DR and this was my BDR. So on the current DR and BDR, just give one command, clear IP OSPF process. If you clear the OSPF process, it will reset the neighborship and DR BDR election will be done again. Understood? So you can read over here, router with the highest priority will become the DR. Default priority on Cisco router is 1, but we can change it manually. If there is a tie in priority, then the highest router ID will break the tie. If the priority is set to 0 of a router, then that router will not participate in DR, BDR election. DR election is not preemptive. Okay, priority can be given from 0 to 255. And if you want any router to become the DR router, again, when it comes up, then you have to clear the IP OSPF process, okay, on the current DR and BDR. Understood?
Yes.
Okay. I can show you practical about this. Okay, I'm not having any topology. So here what I'll take some routers over here. Okay. Now I'll be using some 10 dot network 10.0.0.1/8, 10.0.0.2/8, 10.0.0. Sorry, 3/8, 10.0.0.4/8, 10.0.0.5/8. Okay. Now I'll assign the IP addresses over here on all the routers. Ten dot zero dot zero dot 10.0.0.1 to 55.0.0.0. No shut. No enable config terminal interface fast Ethernet 0/0. IP address 10.0.0.2 to 55.0.0.0. No shut. No enable config terminal interface fast Ethernet 0/0. IP address 10.0.0.3 to 55.0.0.0. Okay, I'll write this configuration, and what I will do, I'll run the OSPF process over here, router OSPF 1, and I'll advertise the 10 dot network. Area 0. Okay, do show history. This will be the command on all the routers. I'll copy this command. Do WR. I'll paste this command over here. Paste the command on all the routers. Okay, I've pasted the command on all the routers. Okay, now DR BDR election will be done. 0, 1, and 2. Okay, now let us have a look. They formed neighborship. Okay, they formed neighborship. Okay, ping 10.0.0.2, 3, 4, 5. Show IP OSPF neighbors. See, I'm having neighborship with 2, 3, 4, and 5 over here, and you can see this my router 0, which is having 10.0.0.1, is my DR other router. How I came to know? DR other will be having a full state neighborship with DR and BDR. DR other will be having full state neighborship with DR and BDR, and DR other and DR other will be having two-way state. DR other and DR other will be stuck at two-way state because they will not exchange any information. Two-way state. See, these are my DR other routers. The state is over here, two-way state. It is the state, the adjacency will not be full. Okay, why these routers became the DR and BDR? Because this is the highest router ID, then this is the second highest router ID. That is why these router became the DR router. Okay, these router became the DR and BDR router. Okay, now show IP interface, show IP OSPF interface, fast Ethernet 0/0. Now you can see over here the priority is this, priority is 1. The state of this router is DR other. The designated router is at 10.0.0.5. Backup designated router is as 10.0.0.4. Okay, this is a type of network, broadcast type of network over here. Understood? Now I want that router 0 should become the DR and router 1 should become the BDR. So what I will do, I'll just change the priority value and clear the process. Okay, on 3 and 4. Okay, so how to change the priority value? I have to go on the interface fast Ethernet 0/0 and I have to say IP OSPF priority. Now you can see I can give the priority from 0 to 255. So I'll give the priority of this router as 255. Okay, and on this router I will give the priority as 254. IP OSPF priority is 254. Okay. Now what I need to do? I need to go on the current DR and BDR router, and I have to give a command over here, clear IP OSPF process. Yes. Okay. On this router also, clear IP OSPF process. Okay. Once I do this, now the neighborship will be going down and the election process will be going again. Okay. Now if I check over here on this router, once the neighborship comes up again, if I see show IP OSPF neighbor, I'm having the neighbor, and still this router is the DR router because something is not. Clear IP OSPF process. Yes. Let me do it on all the routers. This router became the DR now. If I see show designated router is 10.0.0.1, backup designated router is 10.0.0.2. Okay, you can see the priority over here 255, configured priority is 255. Okay, if I see show IP OSPF neighbor over here, you can see the priority values over here also. Okay, and these are my DR other routers. So my DR, I am the DR now. So DR will be having full state neighborship with DR other router. Okay, and also with the BDR router. Now if I go on any other router, suppose this DR other router, and if I see the neighborship, it will be having full state with DR and BDR, and rest of the routers it will be having the two-way state. The neighborship will be stuck at the two-way state. Understood? Any questions? Okay.
Qayyum, Pawan this side.
Yeah, Pawan.
DR other and DR other do not exchange link state database, you said, LSDB?
When is the LSDB is exchanged? On which state the LSDB has been exchanged?
It is at the second like after hello packets.
After hello packet, what happens?
It's send DVD, exchange DVD, right?
These are the states.
Yeah.
Down in it, two-way. Till two-way, I'm not sharing anything. They are just saying hello to each other. They are just saying hello, that okay, I can see you. Router A will say I can see you. Router B will say I can see you. And they will just share their router ID. I am router ID so and so, I can see you. This will see I am router ID so and so, I can see you. Okay. Where the DBD is exchanged in exchange state. Here. Here is my LSDB, link state database. Here is my LSDB, link state database. So if my process is stopped on two-way state, how my router will share the LSDB? Understood? They will share the LSDB with only DR router and BDR router. Every router will share the link state database or any update with the DR and BDR router only. And with the DR other router, a DR other router and a DR other router, the state will be stuck at two-way state. Means they will just know each other that I am on the network, that's it.
Okay.
Okay.
It also exchanges with BDR because BDR will come in role when
So BDR should have all the information.
Oh, okay.
Okay. BDR will sit idle unless the DR go down. The BDR will sit idle like our vice captain. He does not do anything. He just sit idle. Every decision is taken by the captain only. Okay. So like BDR will sit idle and he will just look the process. He will take the information. He will store the information. Once the DR goes down, the BDR should have all the information. That is why we share with DR and BDR both. Understood?
Yes. Okay.
Okay. Now let us move to, we have seen virtual links. Okay, now let us move to, so here is the thing, DR and BDR with DR other will have full state neighborship. DR other with BDR, the same thing, opposite I have written. And DR other with DR other will be having two-way states. And when DR other is sending the updates to DR or BDR, it is sending on this multicast address 224.0.0.6. And when DR is sending the updates to the other routers, it is sending on this address 224.0.0.5. That is the reason it uses two multicast addresses. Got it?
And DR other on the same 5, right?
DR other they will not exchange with each other. That's what I'm telling you. Come on.
Hello messages also goes on multicast.
Hello messages will be on this.
That's what I'm asking. So it will be
224.0.0.5.
Okay.
Initial process will be done on this router only. This multicast address only. 224.0.0.5. Okay. Now LSA types. LSA. Link state advertisement. Now we have some LSA types 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, we have 11 LSA types. We'll study about the LSA types, not about much about 6, 7, 8, 9, 10, 11, but 1, 2, 3, 4, 5. Okay, till 5 we will study. And after that 6, 7, 8, 9, 10, 11 are something above the CCNP level. LSA type 1, router LSA. It is also known as router LSA. Router LSA. Or you can say type 1 LSA. Type 1 LSA. Whenever these are some O routes, you can say, within the area routes. Whenever my router is sharing any routes within the area, that is known as, suppose this is my area. These are my router inside the area. Okay, these are connected. Here is some LAN network. So whatever this is suppose area 0, whatever the updates are shared within this area, internal, which will be internal inside the area only, that is known as my router LSA or type 1 LSA, generated by internal router. Whatever you see O routes in the routing table, floods within area only, does not cross the ABR. Does not cross the ABR, router LSA. They will not cross the area border router. Okay, they will be inside the area only. Floods within the area, LSA type 1. Then we have LSA type 2, network LSA. Network LSA are advertised by DR to the transit network. Means whatever things the DR is advertising to the DR other router are known as network LSAs. Floods within its area only, does not cross ABR. They are also seen as O routes. Router LSA and network LSA. Okay, both are, you can say, somewhat same, but LSA type 2, it used in broadcast network. It is there in the broadcast network, network LSA. They are there, they are present in the broadcast network. Broadcast network uses LSA 2. Okay, O routes are LSA 2 routes. Then comes my LSA 3, summary LSA. Summary LSA. Now type 3 LSA are used to flood network information to areas outside the originating area, means OIA routes. OIA routes, sending updates from one area to another area. OIA routes in the routing table. These are my summary LSA. Advertised by ABR of originating area. Flood throughout the autonomous system. Flood throughout the autonomous system. Summary LSA, in the sense, if I say, I'm having two areas. I will take it. Paint only. I'm having two areas. Okay. Both the areas are connected with a router. I'm having multiple routers inside this area. Okay, inside this area also I'm having multiple routers. Now inside this area, whatever the routes are going inside this area, this is my point-to-point network. So they are LSA 1. They are LSA 1. When this ABR router passes the information about this area route, suppose this is my area 0, this is my area 1. When this area 0 routes are passed to this area in area 1, they become summary LSA. Summary LSA or type 3. Type 3. Summary LSA. Type 3. Okay, when my one area routes are shared with other area, they are my summary LSA. If this area routes are shared with this area, they are also type 3. LSA type 3. Okay, OIA routes, exchanging updates between areas, regenerated by subsequent ABRs. Okay, they are shared by the subsequent ABRs. Understood? And this will be within the autonomous system, within same autonomous system. LSA type 3, summary LSA. Now we have LSA type 4, also known as summary LSA. It is also known as summary LSA. Now LSA type 4 are used to advertise an ASBR to all the other areas. Okay. ASBR, what is an ASBR? What is an ASBR? Suppose this is my Ospf I'm running over here, and there is a routing protocol that I'm running over here. Some routing protocol, suppose I'm running EIGRP over here. Okay, suppose I'm running EIGRP over here. And this is the router that is running EIGRP and Ospf both. So the router that is running two routing protocols is known as my ASBR, Autonomous System Boundary Router or Border Router. ASBR. The router that is running two routing protocols. Here I am running EIGRP. And I want the EIGRP routes inside the Ospf. So what I'll do redistribution. So the router that is running two routing protocols is known as ASBR router. Now how my internal routers or how my this area 1 routers will come to know where is my ASBR. So they will come to know about ASBR, that where is the ASBR located. They will come to know with the help of LSA type 4. Means LSA type 4 information will be passed to the ABR router, and ABR router will pass the information to the area. LSA type 4. Summary LSA. Type 4 and type 3 both are known as summary LSA, but type 4 what does the type 3 does? Type 3 will do advertise my inter area routes, OIA routes. Type 4 will give me the information about ASBR. Who is ASBR? It will tell me that where is ASBR, who is the ASBR router, and that information will be passed by the ABR router. Advertise an ASBR to all the other routers in the autonomous system. This will be advertised by ABR of the originating area. Okay, represented by all ABRs to flood throughout the autonomous system. Okay, they are regenerated by all subsequent ABR to flood throughout the autonomous system. Now, LSA type 4 contain the router ID of the ASBR. Okay, it will contain the router ID of the ASBR. Got it? LSA type 5, external LSA. LSA type 5, it is external LSA. Now type 5 are used to advertise networks from other autonomous systems. Like whatever networks are in EIGRP, to advertise these network. Type 4 just told me about ASBR. Type 5 will advertise my networks of EIGRP in Ospf. Okay, so redistributed into Ospf. Anything that is redistributed into Ospf, advertised and owned by the originating ASBR. So it will be advertised by this ASBR to the other routers. Now this will be flooded throughout the entire autonomous system. Like this will be going to this router, this is the ABR will send it over here. Okay, this is something my LSA type 5. Now advertising router ID is unchanged throughout the autonomous system. Now type 4 LSA is needed to find the ASBR. Type 5 is to see the to when you see when anything is redistributed inside any routing protocol is redistributed inside what? Inside your OSPF. Okay. So type 5 LSAs are used to advertise networks from other autonomous systems. Okay. By default, routes are not summarized by default. Okay. By default, they are not summarized. The routes are not summarized. Got it? Any questions still here? Any doubt? Because these are important. LSA type 5 till here, this is important topic. Any questions still here? LSA type 6. Now this is something that is not of our use, used in multicast routing, multicast OSPF LSA, not supported by Cisco router. This is not supported by Cisco router, so it is not of our use. Then we have LSA 7. Now LSA 7 is something that we'll study. This is known as NSSA LSA. Okay, NSSA LSA. Okay, so we'll study about this NSSA LSA when we will study about stubs. Okay, not so stubby area. So NSSA LSA is something advertises routes in another routing domain generated by an ASBR with a not so stubby area. So what is not so stubby area? I will explain you. Then have LSA type 8, external attribute LSA, used in OSPF and BGP interworking. When we are working with BGP and OSPF both, then we need LSA type 8, external attribute LSA. Then 9, 10, and 11 are known as opaque LSA, used for specific applications such as OSPF and MPLS interworking. So these all LSAs 6, 7, 8, 9, 10, 11, these are not part of our CCNP. Okay, I just gave you the names of these LSAs. Okay, the important at the CCNP level are these 5 LSAs. Okay.
Can you just wait for a minute? I just want to note down something.
Yeah, I'll be right back. Okay. Just note down. I'll be right back in a minute. Done? Is it done?
Yes. Done.
You want LSA 5 also?
Yeah, for a minute just. I will take a screenshot. Then I will note down later.
Can I scroll down?
Yes, yes, please. Done. Go ahead.
Okay, perfect. Now these are my LSA types. Okay. Now after LSA, the LSAs are very important things. Okay. In our OSPF, whenever you will go for anything related to OSPF, whenever you go for an interview and your main focus is on OSPF, then the person will ask you about LSAs. Okay, surely he will ask you about LSAs. Either he will say what is type 1, or he will say what is summary LSA, or he will say what is router LSA, or he will ask you about the type 1, type 2, type 7. Okay, you should know about LSAs. Now we have stubs. Stubs. Now why we use stubs? Why we use stubs? Stub will reduce, it will help in minimizing the size of routing table on edge routers. What it will do? It will help me to minimize the routing table on the edge routers. It will use default route. It will use default route to ABR to communicate with the external and OIA routes. It reduces the number of LSAs within the area. Okay, so in turn, it will reduce memory and CPU resources. If I give you an example of this, suppose if I make an example, suppose this is my head office. This is my head office. And these are my some branch offices over here. Branch office router. And I have some routers over here, some small branch offices over here, or some edge routers, you can say, on all the branch offices. Now these are connected. These are connected. Sorry, I'm using mouse, so it is not so good. I'll make it straight lines only. Okay, and on this router, suppose I'm running some here, I'm running some routing protocol, that is EIGRP. Suppose I'm running some EIGRP protocol over here. Now, suppose these are in different areas. Okay, now suppose what I did, I made this routers to run in area 0. Okay, these all routers are running in area 1. These all are running in area 2. These all are running in area 3. And these are my ABR routers. These are my ABR routers. Okay, area border routers. ABR routers. Okay, ABR. These are what my ABR routers. Okay, now on the edge routers, these are my edge routers. So on the edge routers, if I want to go anywhere, whether if I want to go to the from area 1 to area 2, any router, or from area 1 to area 3, or if I want to go to area from OSPF area to any other external area, where I need to go? I need to go to this router. I need to go to this router, correct? My ABR router. My ABR router will take me to the other area. Now this is something in just an example, just an overview. I have not connected the link or something in between. So, but this is something and just an example. So that is the reason I'm just explaining you this thing. Now, what will happen wherever I want to go? I have to go to my ABR router, and here I will be having there is no need to have individual routes on this router. I don't need individual routes on this router, because there will be a big, if there will be a big network OSPF issue, as I told you, there will be a big network, then routing table will be more bigger for access to the routers. Now a router may run out of the memory, increases the number of advertisement, that is LSAs. So what does my OSPF stub will do if I make any area as stub area? Okay, if I make any area as a stub area, that the routers in that area will stop external LSAs. Okay, they will stop the LSA 5. They will stop LSA 5, the external routes. Okay, they will replace that external routes with simply they will simply replace the routes with O*IA routes. All the external routes, either I want to go to another area, or I want to go to any external routes, that is EIGRP. every external routes will be converted into a default OIA routes. Okay, so I will be having only one route. This route will be there, a default route, default inter-area route, OSPF default inter-area route. Wherever I want to go, I have to go to ABR. Now this ABR will be having all the informations about the network, about all the networks. Okay, this ABR will be having, suppose here in this router, I am having some 100 routes. Okay, I'm having some, all the areas are having some 100 routes. And so how many routes I'm having in the table? 100 O routes. And suppose all the areas are also having 100 routes. So OIA routes, I'll be having 300. OIA routes having 300 in the routing table. Instead of this 300 routes, I will be just having one single this route. So my routing table will be decreased. My routing table will be decreased. OSPF stub will stop your LSA 5. LSA 5, the external LSAs. It reduces the size of routing table. Okay. OSPF stub allows the router in an area to use default routes for forwarding packets to ABR rather than more specific routes. So there is no need on these routers, these edge routers. I don't need any specific routes. Why? Because wherever I want to go, I have to go to the ABR router. So that is the reason it will reduce the memory consumption, CPU processing time on the routers inside the area. Understood? Stubs. What is the use of stubs? Understood or not?
I'm sorry, but little bit no, it's not clear. Okay. OIA is LSA type 3, right?
Yes.
And you said stop LSA 5.
Till LSA type 5. It will stop LSA type 5. External LSAs, whatever the external routes that are coming, okay, it will just advertise whatever OIA routes it has been shared. OIA routes. Okay. Let me open the LSA file over there.
OIA is LSA type 3, right?
These are LSA type 3 routes. Okay. OSPF stubs, what it does, it will stop LSA type 5 till LSA type 5 routes. The stub will stop the LSA type 5, whatever the external routes are coming, whatever the external. See, this thing you will understand when I will do the practical. I will show you practically. Okay.
Okay.
In depth, just understand it will stop external routes. Just understand this thing. When I will give you the when I will show you the things practically, then you will come to know about stubs. Okay. Now you know E1 and E2 routes. What are E1 and E2 routes? External LSAs are stopped. E1 and E2 routes. E1 and E2 routes. Have you heard about E1 and E2 routes?
No.
See, whenever you redistribute anything inside OSPF, suppose I am redistributing this EIGRP inside OSPF. So these routes will be known as either E1 routes or E2 routes. These routes will be known as, these are the type of routes, external routes, type of external routes, E1 and E2. E1 and E2. Okay. So whenever anything is coming externally, coming from external routing protocol, it will replace this E1 and E2 routes with what? OIA routes. with OIA route. Sorry, I just made a mistake over here. These routes will be same in stub. I'm really sorry. These routes will be same in stub. Whatever the external routes I was, that is why you got confused. Whatever the external routes I am receiving, that routes will be replaced with this default route. Understood now? External LSAs are stopped, E1 and E2 routes. Now default route is advertised. If I want to reach if I want to go to EIGRP from this area, I will be having on these routers, I will be having a default route that will take me to the ABR. Still, I have 400 routes over here in my routing table. Still, I have 400 routes in my routing table. Understood?
Where you will run OSPF stub? On the router where EIGRP or the ABR on the left or right corner? ABR?
On the ABR router.
Okay.
Okay. No, no, sorry, not on the ABR. You are asking me about where I will run, where I will make the configuration, stub configuration on all the routers within the area.
On all the routers.
Yes. I have to give a configuration on all the routers. If I want to make any area as a stub area, I'll go on all the routers of that area and I'll say this area will be my stub area. Okay. Understood? I'll show you the configuration. Don't worry about that. Just remember LSA 5, whatever the E1 and E2 routes are there, they are stopped by the stub. They are stopped by stub area. Okay, if I make any area as stub area, I will not get E1 and E2 route. Instead of E1 and E2 route, I will be only having this route. O*IA route. Okay. Then I have totally stub. OSPF totally stub area. Now there is some conditions. There is some condition if you want to run stub. These are the condition. Area 0 cannot be a stub area. Area 0 cannot be a stub area. Area with ASBR cannot be a stub area. Means in our example, we cannot make area 3 as a stub area because it is an ASBR router. We cannot make area 3 as a stub area. So area 3 cannot be a stub area. Area with the ASBR cannot be a stub area. Virtual area cannot be a stub area. Virtual area cannot be a stub area. Understood? Okay. Now we have totally stub, OSPF totally stub. Now, as I told you, I have 100 routes as O routes, 100 routes as O routes, 300 routes as OIA routes. Okay. And I have stopped the external routes and I have only one single OIA routes, O default IA routes. Okay. Now this OSPF totally stub, what it will do? It will do more thing. Now I want to remove this OIA routes because if I want to go to any other area also, I have to go to this ABR. I have to go to this ABR. If I want to go to any other area, I have to go to this ABR. So instead of these routes, instead of these 300 routes, I will only have this default route. Instead of all E1 or E2 routes and OIA routes, I'll be only having one single. So how many is remaining? 100. Now my routing table is of 100 lines only. I'm having only 100 routes in my routing table within the area routes. I'm only having within the area routes. It stops LSA 3 and LSA 5. I don't need to have LSA 3 and LSA 5 information in my routing table at the within the area router. Okay, within the area router. Understood? Getting me or not? If you didn't understood, I'll explain again. Just let me know.
I think I will ask some question during practical.
Okay. Okay, then let us move to the practical part. Let it be, I'll open that topology only. I don't have any topology. Okay, I'll open this topology only, the default one which we are using till now. This topology only I'll use. Just what I'll do, I'll remove this link from here. I'll start all the routers. Okay, so this is my topology. Now my plan is something like this. Over here, I'll be running between R1 and R2 with the loopbacks. I'll be running area 10. Here I'll be running area 0. Here I'll be running area suppose 20. This 4 dot will be in a OSPF only. Okay, the 4 dot network will be in OSPF. The 40 dot network will be also in OSPF. This will be also in OSPF. Okay, area 20. And this loopback on R4, here they will be running inside EIGRP. EIGRP. Okay, this is my plan. Understood the plan? Between R1 and R2, I'll be running area 10. Between R2 and R3, area 0. R3 and R4, area 20. And the loopbacks on the R4 router will be in EIGRP, and I'll redistribute the routes inside the EIGRP, or what I'll do, I'll take some RIP routes over here, RIP version 2. Okay, you can take any of the routing protocol. Now I'll take the console of all the routers. I have the IP addresses pre-configured. Just I need to configure routing protocols. This 4 dot are not there. Okay, sorry, 4 dot are not there. The link is not there in between R1 and R4. There is no link. Okay. Let me take you to the plan. Router OSPF1, I'll say network 10.network 0.255.255.255 area 10, 11.1.network and 11.network.
You are on router 4. Or router 4 there is no 11.
Sorry. I thought I'm on router 1. So router OSPF1 network 10.network area 10, 1.network and 11.network. Router OSPF1 network 20.network. .network will be in area 0. 2.network will be in area 0. 12.network will be also in area 0. And there is 1.network that is in my area 10. Router OSPF1 network 30.network. So I can keep 30.network in any area I want. So I'll keep 30.network in my area 0. Then I have 3.network. 3.network will be in area 20. Then I have 2.network. 2.network will be in area 0. 13.network will be also in area 0. Router OSPF1. On R4, I'll say network 3.network 0.255.255.255 area 20. 40.network. Okay, that's it. Exit. Then router RIP version 2 network 14.network. No auto summary. I'll redistribute the route, redistribute RIP subnets. Redistribute RIP subnets. Okay. If I see over here, show IP route OSPF. This is my OSPF table. You can see I am getting E2 routes. E2 routes over here. OIA routes I am getting E2 routes. Okay. I am getting the E2 routes over here. I am getting OIA routes. From where I am getting the OIA routes? Other area routes. Okay. From where I am getting the E2 routes? E2 routes I am getting from external routing protocol, the 14 dot network, external routing protocol. Okay. Now what is E1 and E2 routes? There are two types of external routes in OSPF, E1 and E2 routes. Suppose these are my routers. Okay, they are connected with each other or in this way, like this, like this, like this. And here, suppose I am running some another routing protocol, either RIP or EIGRP or something. So whenever these routes advertise in OSPF, get advertised in OSPF. Okay. Now suppose there is some cost in between these two router. The cost between these two router is 20. To reach this router, it is between these two router is 40, and here it is 60. And from this router, from here, from EIGRP to reach this router, the cost is suppose 100. Okay. Now, whenever we are using whenever you say, I say E1 routes, O-E1 routes, O-E1 routes. Okay. O-E1 routes means that the routes that are coming external. Now, if you can see here, the cost to reach this router from EIGRP is 100. When it comes over here, the cost will be 120. It will calculate this cost, the cost between these two routers. It will add the cost between these two routers, and here on this router, the cost will become 120. On this router, the cost will become 160 because it will calculate, it will add this 40 into plus 120. Then over here, it will become 220. Okay, because it will add 60 over here. But in E2 routes, it will not happen in this way. If I'm seeing E2 routes, which are the default one, if the cost on this router is 100, if the cost on this router or ABR router is 100, then the cost on all the routers within the autonomous system or within the autonomous system will be 100 only. It will not calculate the different cost. It will not calculate the cost between the routers. The cost on all the routers will be 100 only. Understood? This is the difference between E1 and E2 routes. There are two types of routes in OSPF, external routes, E1 and E2. E2 is by default. If you don't select anything, by default, you will get E2 routes. Understood? So here I am getting E2 routes. Here I am getting E2 routes in my routing table. Okay. And you can see the cost is 20 on all the, because we are on the single router only. So the cost will not change over here. Now I am getting OIA routes. I am getting E2 routes. Okay. If I want to go to this, if I will go on router 2 and if I see show IP route OSPF, here I am getting OIA routes. O routes and E2 routes. Okay, OE2 routes. Now I will configure area 10, which is my area 10. This is my area 10. I'll configure area 10 as my stub area. Stub area. Because if this router is having the information, this is my ABR router. If this router is having the information about OE2 routes, it can take me to the OE2 routes. Okay. So if I want to go to OE2 routes, any of the network, whether it is 14.0.0.1, 1.1, 2.1, any of the OE2 routes, I have to go to my ABR router. Correct? So what I will do, I'll make this area as a stub area. If I make any area as a stub area, I will not get LSA 5 routes inside the area. I'll not get LSA 5 routes inside the area. Okay, so let me show you the difference. So I am on, I want to configure area 10 as stub area, which will stop my LSA 5. Okay.
1 second. On R1, we will not see LSA type 5, right?
Yes. After on R1, we will not see LSA type 5.
Can you go on R1 and just see show IP OSPF database? So I want to see if there is LSA 5, LSA type 4. So type 5 is there, right? Type 5 AS.
These are the type 5 LSAs.
Okay, so this will be wiped after a stub.
From the routing table, I told you. The routes will be removed from the routing table.
Routing table, okay.
From here. Here I will be getting one single route instead of these 4 routes. I will be getting one single OIA default route. Okay.
I think it should also wipe from there because
let us see what happens.
R2, yeah, because R2 is stop LSA type 5, right? So it should also not be there.
What happens? So in order to ensure that no external route should enter in the area 10, we need to configure area 10 as stub area here. Okay. So on all the routers of the OSPF area 10, that is in our example, R1 and R2 are the routers in area 10. You have to give some command. So what command you have to give? You have to go in the router OSPF mode and you have to say one command, area 10 stub. Area 10 stub. On R2 also, router OSPF 1, area 10 stub. Okay, understood? Now I am on R2. If I check show IP OSPF neighbor, my neighbors are these routers 13.0.3.1 and 11.0.3.1. If I go on R1 and if I check show IP OSPF, show IP route OSPF, my external routes, E2 routes are removed and I only have one O star IA route. If I try to ping 14.0.0.1 from here, I am able to reach 14.0.0.1 from here.
This is like default route, right?
This is a default route to my ASBR. Now my ASBR will be having all the informations about the external routes. You can see R2 is the ASBR. ASBR is having all the informations. Okay. So You can see in the output, all the external routes are replaced with a single default route. And still you can reach the external routes on R4. Okay. And understood? Now your question. They are removed?
Yes.
Got it? This is
Can you go
something
on
by
R2?
stub. So R2 will be having the information. R2 is having the routes. Show IP OSPF database.
On R2, you also ran a stub, but here you see those routes.
Because this is my ASBR router. It is running two areas. It is running in two areas. It is not running in only one area. It is also running in area 0. So via area 0, I am getting these routes.
Okay. So we are running two different area there.
Yes.
OSPF area.
Yes. So from area 0, I am getting these routes.
Just wanna correct one. So ASBR definition is when we run two different protocol, right, on a router, then that router becomes ASBR.
Yes.
But here R2 is not ASBR, right? R2 is ABR.
ABR, area border router. ASBR is my R4. R4 is running two routing protocol, RIP and OSPF. ASBR is my R4. Understood?
Yeah, good example. Thanks.
Now this is something my stub area. This is something my stub area. Okay. Now I will configure totally stub. The last thing that we will see today, totally stub. Now I want router, still if I see, I am getting OIA routes. Still my routing table is very huge. Still I am getting OIA routes. Still I am getting OIA routes. So run. Okay. Show run pipe section OSPF. Okay, so still I am getting OIA routes over here. You can see. So if I want to remove this LSA 3s also, LSA 3. If I want to remove this LSA 3, then I need to run totally stub. Totally stub. Okay. If I want to configure area 10 to stop LSA 5, means R1 should not get LSA 5. It should not get LSA 4. It should not get LSA 3. Both the summary LSAs and the LSA 5. Then I will configure the area as totally stub. Okay. So in order to ensure that no external routes and OIA routes should enter into area 10, we need to configure area 10 as totally stub area. Okay. So first I'll remove the configuration, whatever I have done over here, the stub configuration. Okay. I've removed the stub configuration. If I see show IP route OSPF, let it get converged. So I'm getting OIA routes. I'm getting E2 routes also on R1. Now to configure totally stub, what you need to do on all area border router, or sorry, only on all the internal routers, what you need to do, you have to give the command, the same command on all the internal routers. Okay. So here my internal router is only one router, that is R1. As per my diagram, if I go area 10, I am only having one internal router. So on all the internal routers, I have to give one command, that is the same command area 10 stub. On all the internal routers, I have to give this command. Here in my example, I am only having one internal router. On the area border router, you have to give a command area 10 stub and no summary. Only on the ABR router, you have to give this command area 10 and no summary. Got it? Only on ABR router. If I come over here, see, I'm getting only OIA route, a single route I am getting. If I see the routing table here, I am having only one single OIA route. If I try to ping any, the E1 and E2 routes as well as my OIA route replaced with a single default route, and you maintain connectivity still at the cost of reducing the size of routing table. If I try to ping 14.0.0.1, I am able to ping. If I try to ping suppose this 30 dot network, okay, if I try to ping the 30 dot in the LAN 30.1.1.1, still I am able to ping. But from the routing table, the OIA routes are been removed. The OIA routes are been removed. Understood?
Yes, just take show IP Ospf database.
This is my database table. Three, four, 5 are removed.
Yes. Okay. So while troubleshooting, this will give a problem, right?
So we will be knowing that this is the stub area. Okay, so whatever troubleshooting we will be doing on the ABR router. ABR will be having all the individual routes.
So a star indicates as a stub, right? That's a stub have been configured on R1.
Yes. This asterisk will tell you that we have configured stub. We have configured this area as a stub area.
The star comes always when there is a stub, right?
Yes.
Okay.
With O, asterisk will be there.
O is in case of OSPF, right? In case of EIGRP, it will be E star IA, right? Oh, it's different, right? There will be
EIGRP is not stub. EIGRP stub is different.
Okay.
Okay. Any questions? Anything you want to ask? So I have a task for you. I'll give you stub and totally stub task. Okay, I want you to do, all of you to do these things. This will be in area 10. These and these will be in area 0. And these loopbacks will be in any routing protocol. You can say either RIP or either EIGRP, any of the routing protocol. Okay. So this is the task that you need to do as a homework. OSPF stub and totally stub.
Okay. Just write OSPF stub and this and the screenshot I will take.
Where I have to write?
Anywhere. Yeah.
OSPF
stub and totally stub, right?
Just give me this thing. OSPF stub and totally stub. Okay. I'll remove all the other things. Just give me a second. Okay, OSPF stub and totally stub.
Okay.
Now you need to configure area 10 to stop LSA 5 and LSA 4 first. Okay. Then you need to make sure that area 10 routers still able to reach the external routes. That is my 14.network. So first configure stub. Okay. Just this is for your practice. First configure stub. For E2 routes, you should get O*IA routes. Then after that, remove that configuration and configure area 10 to stop LSA 5, LSA 4 and LSA 3. Okay, that is E1, E2 routes and OIA routes. Understood? Totally stub.
Can you just once speak once the redistribution command OSPF into or rip into OSPF?
I just forgot to explain you the redistribution thing. That is my mistake. Okay. So if you want to redistribute RIP, just use RIP only. You have to go in the OSPF mode and you have to give one command, redistribute RIP subnet. That's it. Redistribute RIP subnet on the router that is running both the routing protocol. Got it?
Okay.
Inside router OSPF mode, inside router OSPF mode, you have to give this command, redistribute RIP subnet.
Okay, done. Thanks.
Any questions?
Nothing from my side. Thank you.
Okay, so we'll stop.